Okay, today we're going to start going over Investigation 3, which has to do with these seasons. One of the first things we're going to look at when we start talking about the seasons are the length of hours of daylight that we receive. We looked at some problems in class where we had to solve for the hours of daylight. Some of the problems that we went over in class were looking at sunrise and sunset. So for instance, if we have, let's say, a sunrise, and I will show the answer sheet here. If we have a sunrise and sunset, we can calculate the hours of daylight. And I'm going to do a couple of these problems and work them out. Let's take a look at let's say February. Let's take a look at February, and we'll do February as a practice problem. So if we take a look at February, what we're going to do is we're going to start with 12 noon. And what we're going to do is we're going to subtract our sunrise from that. So our sunrise for February 21st is 6:52. And this is going off of the worksheet that we did in class. So as we go to do our math for this, we need to borrow from the hours column. Okay, when we borrow from the hours column, we only have 60 minutes in an hour. So we're not borrowing 100 minutes in an hour, that's why we borrowed just a 6. We still can't do 0 minus 2, so we need to borrow from that again, making it a 5. And then that makes this a 10. If we think about doing this borrowing as 10 minutes here plus 50 minutes here, that still gives us our hour that we initially borrowed, our 60 minutes total. So now we can do the subtraction for this. So we have 10 minus 2, which is 8. 5 minus 5, 0. 11 minus 6, which is 5. The next thing that we're going to do is we're going to add in the sunset. Going back to that worksheet, our sunset was 5:54. Okay. And when we do our math for this, 8 and 4 is 2. Carry the 1. 6 and 10. The problem with doing this problem is that we get more than 60 minutes here in our minutes column. So our solution to fix that is we need to then subtract 60, which is 1 hour. If we're going to subtract an hour from the minute side, then we need to add that hour back to the hour side. So whatever we do to one side to get our answer in the right form, we need to do the opposite to the other side. So that will give us 11 hours and 2 minutes. And if we go back and check our answer, okay, we see our answer here of 11 hours and 2 minutes. Let's try one more, and for this one we're going to use military time. So for this, let's do August. Annotations. Scroll back up to the top here. Okay, for August, when we work in military time, we have an initial sunset time of 6:53, and that's PM, which is going to convert into 18:53. Since we have that in military time, we can just then subtract our sunrise And for August, the sunrise was 5:30. 3 minus 0 is 3. 5 minus 3 is 2. 18 minus 5 is 13. In this case, our answer of 13 hours and 23 minutes does not need to be changed in any way, and we can double check that with the answer key here. And we can see that for August we got 13 hours and 23 minutes. Alright, I'm going to do one more. Let's do July. Clear annotations. And I'm going to use the standard method for this of subtracting from 12 noon. So for July, we have a sunrise of 5:04, and that's AM. Okay, we're going to have to borrow here, making that a 6. We still need to borrow from that again. Makes it a 5. And we borrowed from that, and that will make this a 10. 10 minus 4 is 6. 5 minus 0, 5. And 11 minus 5 is 6. And then we can add back in our sunset. And for July, our sunset was at 7:26 p.m. 6 and 6 is 2. Carry the 1. 6 and 2 is 8. Okay, and 6 and 7 is 13. The problem with this one, again, is we have an answer here greater than 60 in the minutes column. So again, we're going to have to change that. Okay, where we can then get the minutes and hours correctly. So whatever we do to one side, we need to do the opposite to the other side. So since we're going to subtract an hour from the minute side, we need to add an hour back to our hour side, and that will give us 14 hours. And when we do our subtraction here, we get a 2 and another 2. 22 minutes. And when we go back and look at our answer key, and for July we have 14 hours and 22 minutes. Okay, today we're going to look at sunrise and sunset. Alright, now that we've recorded some of the different problems and how we solved the hours of daylight, we can go down to the bottom of the page and graph the answers to that. When we look at our graph for the answers to that, we kind of see it makes a little bit of a mountain, as we see an increase in January, February, March, April, May. June is the longest day in terms of hours of sunlight, and that would make sense since that is our summer solstice. As we work our way to the second half of the year through July to December, we see in December we have the shortest amount of sunlight, and I have some of this kind of drawn on here. We can see that as we get the hours of daylight increasing, we get warmer temperatures. More sunlight equals higher temperatures. As we start to then hit the second half of the year, we get cooling taking place as we get less hours of sunlight, and we are going to be getting lower temperatures. We look at our meteorological summer being June, July, and August. After we've had longer hours of sunlight, the Earth is warming up. We reach our peak in terms of getting longer hours of sunlight in June, and that's when the Earth should start getting the warmest for July and August, where it'll stay warm. And then we get our coldest or lowest hours of sunlight in the winter, which makes sense. Since we're getting lower hours of sunlight or less hours of sunlight, we're also going to be getting lower temperatures. We're not getting as much energy from the sun. With less energy from the sun, the atmosphere on the Earth is less energetic, and we get lower temperatures on Earth. And we can kind of see here in the middle, we have our fall and our spring, which are almost essentially exactly the same. And those are our transition periods between our summer solstice and our winter solstice. We have our spring and fall equinox. If you have any questions on what we went over in class today, talking about how the hours of sunlight that we get have an effect on